2. We have a packed agenda for the next two days, full of great talks about AD and intra-AD security. So let's not waste any time and start with our first talk. It will be about cross-forest attack paths, a topic that is known for a few years, but I think we will be surprised today. So let's welcome our first speaker of the day, Jonas.
Thank you so much for the introduction. Very happy to be back here at Troopers. Yeah, the best conference of the year for me. So, quick, who am I? Yeah, I'm Jonas. I work as a manager in the research team of SpectraOps. We're primarily focused on analyzing attack techniques, trying to understand how they work and how we can model that in Bloodhound. I've previously worked as a security consulting, helping organizations find and remediate attack paths within Active Directory and implementing security measures such as AD tiering. I'm based in Copenhagen, Denmark. And yeah, it's the third time I'm here at Troopers speaking, so very grateful to be back here. And you can tell by my socks that I've been here before. Yeah. But let's dive into it. So to make sure that we are somewhat on the same page, I want to cover like AD, Forest, and Trust quickly. Also for all the cloud folks that are here, I know yeah, you have migrated up there, so maybe you don't remember the AD stuff anymore. Then we're going to talk about the attack techniques that's possible between forests. And what we'll discover there is there are some abusable scenarios, so we'll naturally also consider like who can create these conditions. At last, I'll give some examples of how you can jump from one AD forest to another when there is no AD trust. So that's the agenda. When you create an Active Directory domain, it will automatically belong to an AD forest. In this domain here, there will be a group called domain admins, and domain admins can control everything within the domain. There's also this group called enterprise admins. It can also control everything. This enterprise admins group only exists in the root domain of a forest. So when you add another domain to the forest, this enterprise admins group will also have control of that domain. So enterprise admins could also be called forest admin because, like, yeah, they control the entire forest, where domain admins only control the domain that they reside in. There'll automatically be created this two-way transitive trust between domains when you add a domain to a forest. And this trust in Active Directory, it enables authentication across the domains, such that users of one domain can be granted access to resources in another domain. By default, you just have authenticated users access in the other domain, so you can read stuff without having been granted any custom permissions. But then, like an admin could, for example, give you write access to a file share in the other domain, and that will work because of the trust. Because the trust is transitive, when you have like more domains in a forest, it means that all domains will really trust each other. So even a user in one of these child domains can be granted access to any of the other domains within the forest. It is possible to set up trust between forests as well. And the most common trust type is the forest trust, which you create from a forest root domain to another forest root domain. It can either be a one-way trust, meaning that you only get access in one direction. It can also be a two-way, so it's bidirectional. This trust is also transitive, so it means that all the child domains within the forest can also access all domains of the other forest. There's also a more granular trust type, which is called the external trust. And it can be set up between any domains within a forest to any domain within another forest. And it's just these two domains that will trust each other. At least that's how it's supposed to work. There are ways to circumvent that as an attacker. But yeah, that's outside the scope for today. There's a third type of cross-forest trust called Kerberos trust or realm trust, and that's for setting up a trust to a non-Windows environment. I will also not cover that in this talk here today. It's not something I've looked into, to be honest. These external trust and forest trust are quite common in large organizations that have like multiple forests though. So, Microsoft states that the forest is a security boundary. That means that enterprise admins, they can control their own forest, but they cannot control other forests that you set up a trust relationship with. Don't get me wrong, it's definitely possible to grant full control to enterprise admins of another forest, such that enterprise admins can control multiple forests, but by default, at least, there is the security boundary that protects forests from each other. They also state that the domain is not a security boundary. So what does that mean? Why is the domain not a security boundary? It would be natural to think that the domain is a security boundary when domain admins can only control their own domain. So the forest root domain can control everything, but child domains should not be able to control each other. Microsoft states that it's not possible to prevent a malicious administrator from gaining access to your data in another domain. It don't really specify how it's possible for a malicious actor. It's something I have looked into a few times, and have a link here to a talk I gave 2 months ago where I do a deep dive on that topic. But the TLDR is that, first of all, these trusts within a forest here, they have a weak configuration by default, which allows a couple of attacks. And then there's also this configuration naming context, which is stored on every DC in the entire forest, and every DC can write to it. And this configuration naming context contains the configuration for systems like ADCS and also the sites of the forest. So an attacker can abuse that write access to compromise the entire forest. So that's why the domain is not a security boundary, at least to my knowledge. So that was the quick introduction. Now let's talk about some attack techniques. So within a forest, we had these two things that enable some attack paths. Could some of these also apply to trust relationships between forests? Well, we can rule out the second one here because the configuration naming context is stored in each forest, and domain controllers do not have write access to a configuration naming context in another forest. That's not a thing, so yeah, we can rule that out. However, it is possible to configure trusts, both for within the forest, but also across forest trusts, so that's worth looking into. The trust configuration is stored on these objects called trusted domain objects, which are created automatically when you set up a trust. The object has the name of the domain that you are establishing a trust relationship with, and they're created no matter if it's a one-way trust or a two-way trust. This object has an attribute called trust attributes, which is just an integer value. It's a bit mask value, so it represents some flags that are enabled, which are really the settings of the trust. So here in this screenshot here, we have the trust attribute set to 32. That corresponds to the hex value 20. And if you look up the documentation, we'll see that corresponds to this flag called within forest. And yeah, it just means that this trust relationship is within a forest. So it's the same forest trust. These trust attributes are kind of interesting and a bit difficult to understand. At least that was the case for me. Here we have another example. We have an inbound forest trust. It has the trust attributes 2056. And we can see that this TTT delegation thing is set to true on this trust here. And this value here means that the forest transitive flag is enabled, which just means that it's a forest trust. And secondly, it has this enable TTT delegation flag as well. So that's also why we see the value is true up in the highlighted box here. Now, when we look at this trust from the other direction, so from the outbound side, we just see that the trust attributes is set to 8 and TDT delegation is false. So why is that? That's because these settings can be set on both sides of the trust. And this trust attribute's value is not synchronized between the domains. So it can be quite confusing because if you're auditing the trust and want to figure out is TDT delegation enabled, which side of the trust should you really trust here in this case? Because like there's only one of these sides that can hold the truth. I think I have some mic issues, or maybe it's my ears, so an ear issue. I think we're good now. Yeah, I was just told before the talk that my ears were too big. Never heard that before. But that creates a confusing experience as a user. At least I was confused by this. And it gets even more confusing if you have like a bidirectional trust, because this setting is only gonna affect one of the directions of access. But if it's configured on the other side, it applies to the other access that's granted. So you just have to know which sides to look at when you're trying to figure out if this setting applies to the access that you care about. And it's not super well documented by Microsoft. Does anybody know which side is correct here? Is it the inbound or outbound side that holds the true value for TDT delegation? Almost correct. Try again. Yeah. So it's actually the inbound side, and you would then think, okay, so it's the inbound side that holds like the true values for these trust attributes. But that's only for TDT delegation. For other settings, you need to look at the outbound side. So it's kind of confusing, and you have to like understand trust very well to understand like what direction it makes sense for, and yeah, the documentation is lacking on this area here. But first attack, let's see how TDT delegation can be abused. So some years ago, my colleague Will Schroeder, he wrote an article about how you can break forest trust by abusing TDT delegation. And the attack can be summarized with this, this figure here. So let's say we have compromised this DCB domain controller in one forest, and we want to attack the DCA server, which is also a domain controller, in another forest. First, we coerce the target DC, and in this example, we are using the printer bug, and the coercion will make the target DC authenticate back to us, and because TDT delegation is enabled, it means that this server over there is allowed to send its TDT to us when it's authenticating, and a domain controller will have unconstrained delegation enabled by default. So it means that principals that are authenticating to it will send their TDT. So that happens, we get the TDT of the target server, and with the TDT of a domain controller, we can perform DC sync and obtain the credentials of any account in the target environment. So soon after Will published this post here, Microsoft issued a patch such that this wouldn't work on cross-forest trust by default. Now you need to have this enable TDT delegation flag enabled on the trust, which is not the case by default. And it is on the inbound side, which kind of makes sense because it is like on the target side, you need to configure this flag here. So as an attacker, you cannot like configure this from the attacker-controlled environment. So it makes sense at least, but can be a bit difficult to understand. It also works over a one-way trust. You just need to have a trust from the attacker environment to the target environment. The only challenge is to get the coercion to work. And in order to trigger a coercion, you typically need to have authenticated users access in the target environment. Without the two-way trust, then that's not granted explicitly. So What you can do is to use the trust account, which is created for every trust relationship, and the trust keys that are the credentials of this account is stored on both sides of the trust. So an attacker can dump these credentials from the attacker-controlled environment and use that trust account to obtain a session, and then use that account to perform the coercion, and then, yeah, the attack will work. Second attack is spoof history. So it was an attack found by the great Dirk-Jan, who's also giving a talk this week here at Troopers. I recommend seeing that one. It's always interesting what he finds. But this was back when, before Dirk-Jan turned cloud only. He was still like doing on-prem research, and he found that you can add a target's SID to your SID history, and then you can get treated as the target. This concept was not entirely new. It was also found by Sean Metcalf. He discovered that you could use this concept within a forest to compromise the entire forest, and there again found what the conditions were to execute the attack between forests. So let's look at this attack here. So before I explain the attack itself, I want to go through like what an AD migration looks like. I've never done an AD migration, so there might be some details that are left out. But the concept is that we have a user here called Alice, and Alice has admin rights to her computer here. Now we migrate Alice to another domain, and when we do that, Alice gets a new SID. That's because the SID, her identifier, is based on the domain that she resides in. So when you move to another domain, you need a new SID. That also means that Alice has no longer access to her computer because access is granted based on her SID. So that's of course a problem because we haven't migrated Alice's computer yet. However, the SID history concept can save the day. So it's a property on an AD user that holds like the previous SIDs that you used to have before you were migrated. And then if it is enabled, then on the target environment, it can grant you access based on the SIDs that you have in your SID history. So you can of course abuse this concept. So imagine that we have like this user Bob of a completely different domain here. Then Bob, he does not have admin access to Alice's PC, but if he managed to add Alice's old SID to his SID history, then he suddenly have access to this computer. It's not required that an AD migration has happened, and you can also impersonate principals that haven't been moved out of the environment. You can even like impersonate a group. But yeah, this is the concept of the attack. It is, however, quite difficult to change the SID history of a user. There used to be a way to do it with Mimikatz. It still works on server 2016 and earlier versions, but it'll just crash the DC on later versions. So yeah, I don't recommend that one. Then there's like this AD or DS internals function here. That Michael Grafnader made, who's also here and also giving a talk this week on Friday, so yeah, also recommend that one. And I talked to Michael about this function here earlier today, and he said that it's not part of DS internals anymore. But yeah, you can find it in earlier versions. There was some issues with it when you're doing, I think, mailbox migration with Exchange, so he decided to move it out so people are not screwing up their environments and had to do a full AD forest restore. But yeah, you need to have full control over a domain controller in order to tamper with this attribute. Full control over the account is not enough to write to it. Even if you run a system, you cannot directly tamper with this attribute. So it is protected, and you need to do some hacky things to change the property of a user. There's a second option that's much easier. You can create a Kerberos TDT where you have modified the SID history or the extra SIDs to contain additional SIDs. So yeah, creating a golden ticket or diamond ticket. Or you could also do it in the inter-realm TDT that you get when you access another domain. But of course, these two Other options, option 2 and 3, they are specific to Kerberos. So if you want to do NC-lemma authentication, you probably need to go with the first option. So who can you target? Well, within the domain, you can just target enterprise admins, and the attack is pretty easy to execute. But for cross-forest trust, SID filtering will always filter out the SIDs that ends with a RID that's below 1,000. So groups like enterprise admins are out of the scope. You cannot add that, or you can add it, but it will be filtered out. Also, like domain admins and administrators and so on cannot be added. Makes sense to think like, well, then I'm just going to take a member of any of these groups and add that to my SID, and then I'm enterprise admin. But that also does not work, because memberships are not applied based on the SID history, not for global and universal groups. So you need to be a bit more creative when you are pulling off the attack. There are still some pretty common targets you can use. You can use the Exchange Windows Permissions group, which exists in every AD environment that has ever had on-premise Exchange, and it typically has tier 0 permissions, so that's a pretty good one. Then there's intra-ID sync accounts, which has typically DC sync permissions, and you can actually also target domain controllers, and they do exist in every environment. However, that requires a resource-based constraint delegation attack. So to pull that off, you need to have an account in the target environment, which can, of course, be a challenge. You could potentially execute this attack to first compromise a user that can add a computer to the environment and then perform the resource-based constraint delegation attack. But that's making the steps a bit more. It'll take a bit longer to get there. Should work though. At last, so what are the requirements for this attack here? Well, we need this cross-forest trust, and it needs to go from the target to the attacker forest. So it's the opposite direction of the first attack that we talked about. And then it needs to have a weak SID filtering configured on the outbound side. So this time it's the outbound side. Again, it also makes sense because it is the target environment that we are attacking that controls this setting here. For the trust attributes, it requires that a forest trust needs to have this treat as external flag added. By default, forest trusts are safe. And for external trust, it needs to have this quarantine flag removed. So external trust has this flag here that protects them by default. But if you remove it, then then you can pull off the attack. So if you perform any of these changes, then your KDC will start checking SIDs basically like this guy here. I've made some changes to some of the Bloodhound edges to better model what's possible for these kind of attacks here. So first of all, we have replaced the trusted by edge with these two new edges called cross forest trust and same forest trust. And as the name implies, the cross forest trust edges are for trust relationships between forests, and same forest trust is for within the forest. So for the same forest trust, you know that like these domains belong into the same forest, so there's always like a way to get from one of them to the other. That's also why we have that edge as a traversable edge. So it's included in Bloodhound pathfinding. So when you search for a path from A to B, then this edge might show up. For the cross-forest trust, it depends on the configuration. So this edge is not included in pathfinding. So you avoid these like false positive. And you still want to know about like if there is an abusable configuration for a cross-forest trust. So we have also added two additional edges specifically for these attacks that could be possible. So if there is a cross-forest trust edge that has this spoof SID history blocked set to false, then we create an additional edge called spoof SID history on top, which is traversable, so you can see that there is like a possible abuse here. Similarly, we create this abuse TDT delegation edge, which can help you find cases where that attack is possible. So hopefully this should make it easier to audit AD trusts and find attack paths and avoid these like false positive paths that we have had in the past. Cool. So that was the two attack techniques that I found was possible based on the trust attributes configuration. Now I want to talk about like what the permissions are required to actually set up such an abusable cross-forest trust here. So who can create AD trusts? That's domain admins and enterprise admins. That's not very interesting because if you are a member of any of these groups, then you already own the domain, right? But there's also a group called Incoming Forest Trust Builders. How many of you have heard about this group before? That's a few hands. That's pretty cool. I have not heard about it when I stumbled across it some time ago. But yeah, as the description says, it can create inbound forest trusts. It's an interesting group. It has this like create inbound forest trust extended right on the domain, and that is the permission that allows you to create these like inbound forest trusts. So you can also grant that permission to another account, and they will also be able to do it. They don't need to be a member of this group here. The group is not admin SD holder protected, meaning that Microsoft seems to see it as not like an essential part of tier 0. And that has made me think, like there's not much documentation about the group, but it seems like it's a way for organizations to set up forest trust without having to give the other organization enterprise admin credentials. So if you're establishing a trust and you don't trust the other environment completely, then you could like add a member to this group and give them credentials for that user, so you can set up the trust and without compromising your own environment. So we just learned that inbound trust can be abusable if it has like TTT delegation enabled. So I thought it would be natural to test whether or not this group can create these abusable trusts. I didn't realize that was just me like starting to dive into a rabbit hole. But I hope you will join me in the rabbit hole here. So I tried a couple of different ways to create a trust with TTT delegation enabled. First I tried using the GUI. There's this wizard here, but in that there's no option to enable TTT delegation, so that didn't work. Then I tried the CMD way. There's a tool called netdom that has this trust command you can use to set up trust and modify trust. And it actually has this enable TTT delegation flag. But that flag is only for modifying existing trust. So I couldn't like use it to create a trust with TTT delegation. So third attempt was to make this change after the creation, but that also had some challenges because like only domain admins and enterprise admins can modify existing trusts. When you create an AD trust, then domain admins become the owner of the object, and the only permission you get as the creator is that you can delete the trust. So you cannot like set this trust attributes to have the TTT delegation enabled. So I was wondering, like, is this just a client-side limitation, or is there something on the backend that actually prevents you from creating TTT delegation enabled on trusts? So I wanted to explore like how trusts are created under the hood, and I was slowly falling down in that rabbit hole I entered on the previous slide. So I started up Wireshark to check like what happens when you establish a trust either using the GUI and using netdom, and I was immediately very confused because like that's not something I usually do, like look at Wireshark network traffic. But I got a lot of help from some colleagues and found that there are these RPC calls or procedures that are essential. You first like need to call this open policy to get this session going, and then you need to call this create trusted domain function, and at last you set some information about the trust, and then the trust is created. if we jump into the create trusted domain function, we'll see that there is an input. It's called trusted domain information. And if you look that up, then we can see that there is the trust attributes. So it looks like we can actually just specify the trust attributes when we create the trust. However, if we look up the struct for this parameter here, we'll see it only contains a subset of all the trusted attributes that's supported for the actual value. So enable TTT delegation is missing in the documentation. So that made me wonder, like, maybe Microsoft just forgot to add it, or maybe just don't want us to know that it's possible to enable TTT delegation at creation. Anyway, I decided that I had to test it, so diving deeper into in the rabbit hole. So I wanted to create a POC for establishing trusts, and I decided to use the best programming language in the world, PowerShell. Yeah. And it's pretty difficult to interact with RPC from PowerShell, but luckily the nice James Forshaw has made this project called NC Object Manager, which makes it somewhat easy to interact with RPC. Then I had another trouble I ran into, and that was like this function here for creating the trust takes like the AES encrypted trust keys for the creation, and I struggled a long time figuring out how to do that in PowerShell. Never got it working, but then I found that there's another function that takes the plain text trust password. Very nice. Yeah, that made it much easier. So I tested my script, set the trust attributes to 2056 for having a forest trust with TTT delegation enabled, and it worked. It had the trust attributes set to the value that I wanted. So now I just had to test the remaining part of the attack to coerce the target DC and receive its TTT and compromise the environment. And coercion failed. So just as I thought I hit the bottom of my rabbit hole, I discovered that there was like a whole another level that I hadn't gone down to yet. So yeah. So why do you think coercion failed, specifically for Kerberos? Any ideas? It is, of course, DNS. Yeah. So Kerberos requires DNS for authentication, and if you follow Microsoft guidelines for setting up a forest trust, it'll tell you to create these like DNS conditional forwarders, and that will enable Kerberos authentication across the trust. But only DNS admins and domain admins can create these conditional forwarders. So and not members of this group here, incoming forest trust builders. So I felt pretty much like the fish in Finding Nemo, where they managed to escape from the aquarium, but they're still trapped in these plastic bags. So like they're not really there yet. It's kind of a frustrating situation. So after crying for some hours, I tried to change my perspective of the problem that I was dealing with, and I reached out to a colleague to help me figure out like how common is it to have this group here populated. And he helped me discover that like it has 0 members in almost all our Bloodhound Enterprise customers. So maybe that's not that interesting then. So who can then control the group? Because that could be interesting, right? If you could just add yourself to the group. And again, because this group is not admin SD holder protected, it means that it will have inherent permissions. It also means that account operators can control it. And account operators can actually also control DNS admins, because that's also not admin SD holder protected. So I just had to change things up a bit, and then it suddenly was an attack from account operators. But of course, account operators is maybe not that interesting, because account operators have typically a path to domain admins in most environments anyway. So that's because account operators have full control over all the users and groups and non-DC computers that are not protected by admin SD holder. So there's typically some accounts that that have tier 0 control without being protected by admin SD holder. But yeah, most of these attack paths that account arrays rely on, they're due to custom permissions or some weak configurations. So I still thought it's probably still worth talking about, because this attack here should work in a vanilla Active Directory environment. It just requires that we're dealing with a root domain of the forest, and DNS is hosted within Active Directory, which it is by default. So yeah, decided to continue on it. And here's the concept of the attack. So we have a user called target, or a user of the target environment here called operator. And the operator here is a member of account operators. The first thing the operator will do is to add himself to the incoming forest trust builders and DNS admins. From there, the operator will set up fake domain on the network, called attacker.local here, and then establish a trust relationship from the attacker.local to the target environment here, with TTT delegation enabled. And the operator will also set up the DNS conditional forwarders using the DNS admin permissions, such that the DNS works and Kerberos works. After that, the attacker can perform the coercion. So the operator logs into a computer with unconstrained delegation in this fake domain that he has set up. And then he coerces the DC, through the printer bug or petit botam or some of the other coercion techniques. And that'll make the DC authenticate back to the operator on the box with unconstrained delegation. And it will send its TTT to the operator. And with that TTT, the operator can perform DC sync and obtain the password material of any user in the target environment. So that is how the attack goes. I think there should be time enough for a small demo. So he'll execute the attack. So I've set up a malicious server on the network and promoted it to be a domain controller for its own small environment here. And we have this operator user that has account arrays access in the target environment. First, we need to set up the DNS conditional forwarders in the attacker-controlled box, and then we create an outgoing forest trust to the target environment. So we open up domains and trust here, and under the trust, we create a new trust, and we specify it should be to the target.local environment, and we specify it should be a forest trust, and it should be a one-way outgoing trust. And we set up forest-wide authentication, and we need a password for the trust. And summer 2025 exclamation mark is the password of the season, if you were not aware. So click next, and yes, confirm the outgoing trust. And then the trust is created. On the attacker side, we of course haven't created it on the target side yet. Then we need to add our operator account to these groups that enables the attack. So we start a runner session as the operator account. And first we need to go back a few bits to make it more easy to see what we're doing. And then we add ourselves to the incoming Forest Trust Builders group and the DNS admins group in the target environment. And after that, we need to clear our Kerberos tickets because we now got new memberships, so we need to be treated as these groups, so we need new Kerberos tickets. And then we are going to use a tool called Trustify to set up this malicious trust in the target environment with TTT delegation enabled. Then we're going to verify that the trust was actually created, and we can see the trust attributes 2056, and TTT delegation is enabled here. So now we create the conditional forwarder in the target environment, so Kerberos will work. And that's done with this one-liner. And next, we're going to coerce the target DC. First, we're going to set up Rubius to monitor for incoming TDTs on our attacker box. We already have some TDTs in memory. That's for other principles like the local DC and the operator that we logged in with. But we don't have the target DC yet. Then we're going to use spool sample to perform the coercion of the target DC. And it says that it worked. So we go back here and we see, if we scroll up a bit, that we got the TDT for the target DC. And with that, we can perform DC sync. So once again, we clear our Kerberos tickets. And then we inject the TDT we received into memory using Rubius. Pass the ticket. So we copy the base64 encoded ticket and paste it there so we get it into memory and it's imported. So now we can start Mimikatz and perform DC sync with Mimikatz, and we specify that we should we DC sync the built-in administrator account of the target environment, and we receive all the password hashes or the password hashes of this account here. So that's the attack. I reported this to Microsoft because I thought it was an issue that this incoming Forest Trust Builders group can create these abusable trusts when it's not really a tier 0 group. It's pretty unknown, so people are not aware that it's a group that they should protect. And they deemed it as moderate security, so no patch. They did update the description of the group in at least some of their documentation. So it now has this new part here that says that the group can create trust with TDT delegation enabled, which can lead to compromise of your forest. So at least there's some more information about the group out there. So yeah, wasn't for nothing. I used this tool called Trustify in the demo. So when Microsoft decided that they were not going to patch the issue, I thought that then we should probably do something and create like a proper tool that so others can replicate the issue and yeah, confirm that it is working in environments. And my POC tool was crap. It didn't work on most OS versions, and yeah. So I reached out to my friend and colleague Valdemar Kari, and you can tell by this picture here, he's a lead hacker. He is really good. Like yeah, it's more technical than I am. So he helped me create a tool that can create forest trust with TDT delegation enabled. And yeah, he's smarter than me, so he just found that you could use this DLL instead of interacting with RPC directly, so it made it much easier to do. The tool is available on GitHub, so yeah, you can check it out if you like. So that was the creation of abusable forest trusts or cross-forest trusts. Now to a few examples of what you can do if there is no trust relationships. Also quickly want to mention, like, just because a trust is not configured to be abusable, there could still, of course, be attack paths. Like, it's possible to delegate access as soon as you have a trust relationship. So yeah, it's definitely possible to still find attack paths. So it doesn't mean that there's no attack paths. And yeah, even without trust, there can still be attack paths. ADCS, one of my favorite topics, can enable attack paths between forests without trust. So we have a screenshot from a custom environment where they have a server hosting the CA service for ADCS. And the CA here is trusted for NC authentication in 2 separate forests. I'm not going to lie to you, there is actually a forest trust between these 2 domains here, but it's actually not required. like you can set up trust to certificates manually on DCs or in ADCS, such that like you can enroll a certificate in one forest and then use it in another forest to compromise an environment. So that's something to be aware of. This setup, I've seen this setup in at least like a handful of customers so far. So that's one example. SCCM, which stands for Configuration Manager, apparently. I know very little about SCCM, but my colleague Chris Thompson, he made me aware that it is possible to set up SCCM. So SCCM is a system for managing devices, so you can deploy scripts and updates and whatnot on all the devices that you manage through SCCM. And it's possible to manage the device that's not in the forest that your SCCM site server belongs to, and there's no trust relationship between them. That's a supported thing. So yeah, SCCM could potentially also allow these like cross-forest attack paths without trust. My colleague Dwayne and Garrett are giving a talk tomorrow on SCCM, where they'll probably explain some more interesting stuff about SCCM. So also recommend that talk. Yeah. And intra ID sync. So if you're synchronizing your users or groups or objects up into intra, then there could potentially also be an attack path to another AD environment that you don't have a trust relationship with. There's, I think, many narratives in this area here. You could, of course, have permissions in intra that enables you to compromise other objects of another forest. Maybe you're hosting like servers, even domain controllers in Azure. There are many cool things you can do there if you have like synchronization set up. My colleague Daniel Heinzen has given a talk on this topic recently that I recommend checking out if that's a topic you're interested in. So this was 3 examples of potential attack paths between forests without trust. But these are, of course, just like examples of technologies that could enable these attacks. But yeah, it doesn't mean that if you don't have ADCS, then you're completely safe. You could easily like create these attack paths also with other PKI solutions, and the same for endpoint management and single sign-on and so on. And yeah, there are also other systems that could be relevant to consider. So I think it's very important to take a holistic perspective when you are analyzing who can actually compromise your AD forest. The key takeaways from my talk is that the forest is a security boundary, but that's only until you weaken the configuration of the trust. So yeah, enabling administrators of another forest to compromise your environment. You should probably treat account operators, DNS admins, and incoming forest trust builders as tier 0, meaning that you should protect it pretty much as well as you do with your domain admins. I would definitely recommend that. Last thing is that there can be attack paths between forests even if there's no trust, so don't assume that there's no attack paths if there's no trust. So yeah. I'll release 2 blog posts today that talk about some of the things that I discussed today. So and there's also a link to the demo if you want to see it again. Yeah, so you can check that out if you like. Thank you so much for the time and attention.
Thank you. Great stuff. Are there any questions? We have some time for questions.
I'm sorry if I have missed it, but you know, when you were trying to do a conditional forwarding for the DNS, weren't you just thinking about using some DNS zone which is like publicly forwarded or trusted?
Yeah, so that's actually a good question. I was trying to think of different ways to get the coercion to work, and yeah, it did work over NCLM if I was just using the IP address, so it was limited to DNS and Kerber was there for. I tried different things, like, for example, creating a DNS-A record, because authenticated users can create those, so maybe I could get it to work with that. That didn't work. I also tried to do a couple of other things, but I believe, like, if you're setting up zones in DNS, that also requires high privileges.
Yeah, but once you have a domain controller, which is a DNS, and it has access to the internet, like, so he has root hints or he has DNS forwarders. So you would create your own, like, Etiquer's domain, or first would be called like something.company.com,
Right.
so it would be reachable over the internet, or like resolvable through the internet.
Yeah, I actually also tried doing that, and I could get authentication to go there, but it didn't realize that it was a different forest and like the unconstrained delegation part. So I didn't get a TDT when I tried that. I only tried like a couple of different things before I gave up. So there could be some cases, but I believe I did try to name the attacker environment the same as the target environment, but with another like subdomain added, and yeah, that didn't work for me either. So yeah, but maybe there's some ways around it. I don't know much about DNS to be honest.
Any other questions?
Yeah, so you said that incoming forest trust builders was not protected by admin SD holder. So would you recommend organizations to add this protection? So configuring admin count equals 1, like in each and every AD environment?
That's a good question. I think I have to ask Jim Sakura about it, but I believe when you add like the admin count 1, it will not trigger admin SD holder to protect an account. I think it's the other way around. So it's something that happens after you're protected. You can still potentially make it protected if you could set up a distribution group which cannot have any permissions, and I think add the security group to it. I'm not even sure that's possible. Might not. No, it's not possible. Okay. So I think it's probably a better approach it resides in the built-in container, and I believe you cannot move groups outside of the built-in container, so that's not an option. I don't have any good recommendations to be honest, but it was a valid and good question.
Thanks.
Any more questions? Okay, then thanks again, Jonas.
Thank you.